Hey everybody, today we have a five-term geometric sequence with a couple of properties. And so let me write down what we mean by that. We'll say f is the first term, and that's what we're looking for, folks. We're looking for the first term f. But geometric sequence is related by something called the common ratio, because the ratio of successive terms is always constant, basically, is what's going on with that. So I'll just write down what we're talking about here. R would be the common ratio. It's five terms. F is the first term. And you can see just by construction, the ratio of successive elements here is R. Okay, so we have five terms. And again, one way of saying it, I guess, is the ratio of a successor to its predecessor is always R. Okay, so we want to calculate the first term, so this is what we're interested in. All right, so now we're given the fifth term is equal to this value, and this is the fifth term, right? The 1, 2, 3, 4, 5. So the fifth term is actually 169 over 64. Also the product. Now the product, this takes a little bit, but this part right here is the product. The first three terms, and if you just take a look at these first three terms, if you juxtapose all of them, you get f cubed, but you have r to the first here, and so that's why you get f cubed r cubed. So it's important as far as notation to write this down, okay? And we're given that the product of the first four terms is 13 root 13, okay? Now right here, this is just some substitution right here. This is f cubed. So from this statement right here, we get that f is certainly equal to 169 over the product of 64 times r to the fourth. So y'all, it's not a big y, it's direct substitution, solving for f here, and then substituting it right here. Okay, now so the arithmetic here ensues, and we end up with this statement right here. Okay, we end up with this object right here, and maybe if you don't see why that's happening, 13 to the sixth, here's how I remember it without doing rational exponents. That's the same thing as the square root of 13 raised to the 12th power. Okay, that's real useful when you notice right here you have this part right here would be the square root of 13 cubed, right? And so 12 minus 13 cubed, square root of 13 cubed would be the 9 that you see right here. Okay, again, not having to, I don't like rational exponents that much, but so anyway, hopefully this is all clear. So we get down to this position where we have r to the ninth is equal to this. So if you take, I think I got room right here. If you take the ninth root of both sides from here to here, you get r is equal to root 13 upstairs. That's nice, right? The ninth root of something raised to the ninth power is the something, right? Now here, folks, this is the ninth root of 64 raised to the third power. Okay, but that would be 64 to the 1/3, right? And we are, I guess, using rational exponents there, but you could think of it as radical notation as well. And so anyway, this is equal to, we found our common ratio, which is good news, square root of 13 over 4. So that is the common ratio of our five-element geometric progression. Okay, so r is equal to this. That's not what we're looking for. We're looking for the fifth term. And so a little bit of substitution to do right here. Let's see here. So this would be f times this raised to the fourth power, right, folks? Okay, but this raised to the fourth power would be, let me just write this, 169 over 256. Right, folks, and again, here is our r right here, right? This is our r, and we're raising it to the 4th power. So the square root of 13, similar thing, it would just give you 13 squared, which is 169. And 4 to the 4th is 164, is 256, right? So this is equal to 169 over 64, right? But by inspection, that forces f to be equal to 4. I like the problem. Hope you did too. So f equals to 4. And who would have thought it in the middle of a bunch of all these irrational values? But we did have a little bit of a clue right here with 64, which is what, 4 cubed? Okay. But anyway, that gets the job done. So f equals to 4. I don't think the Rhino cares much about the outcome of this problem. Looking for something to eat, I'm sure. The first term of g is f equals 4. All right. Thanks for viewing.